Okay, so now I will just touch on the chemical formula of covalent compounds, right? So just now we went rather in depth into talking about the chemical formula for ionic compounds, okay? Um, so now we'll just talk briefly about covalent compounds, right? The chemical formula for covalent compounds, right? So just have to know that the rules above that apply to ionic compounds, okay, the naming of ionic compounds, okay, do not apply, okay, to the covalent compounds, right? So basically, you do not apply the valency rule, for example, okay, in the naming of or deducing the chemical formula of covalent compounds, right? So the valency rule will not apply to covalent compounds, okay? Just have to know that. So just briefly talk about what are covalent compounds, okay? So ionic compounds basically, as we have explained just now, okay, an ionic compound is made up of ions, okay, which are elements that have gained a charge, right? So they gain a charge because they gain or lose electrons, right? On the other hand, covalent compounds, okay, they do not, I repeat, they do not gain or lose electrons, but instead they share electrons, okay? And in ionic compounds, just now we learned that they usually consist of a metal and a non-metal, right? However, the opposite is true for covalent compounds. Covalent compounds are formed only between non-metals, right? So okay, basically it's just covalent compounds, okay, are formed by the sharing of electrons, okay, between non-metals, right? And equally, usually these electrons are shared equally between the elements, okay, the atoms of the elements, but there are also exceptions, okay, to this rule. So basically just have to know that different elements, okay, share different numbers of electrons with one another. So there is no like general rule, okay, that you will learn at this level, okay, that you can use to actually just sort of derive the chemical formulas, okay, of covalent compounds, right? So instead, we'll adopt a much simpler approach, which is we just look at the names of the covalent compounds, okay, to deduce the chemical formula, right? So we actually deduce the chemical formula just by looking at the names of the covalent compounds, okay? So that's what we'll mostly be doing, okay? So for example, okay, in this case we'll look at diatomic gas molecules. Okay, so in the periodic table, okay, those elements that are in group 7, okay, and some of them in group 6, right, they will actually exist as diatomic gas molecules. So previously we did see an example involving hydrogen, the reaction between hydrogen gas and nitrogen gas to form ammonia. Okay, so hydrogen and nitrogen gas are two examples of elements that exist as diatomic gas molecules, right? They are gases and they are diatomic, meaning that there are two of such atoms of that element, okay, within each molecule, right? Okay, so other examples will be bromine, iodine, chlorine, oxygen, and fluorine, right? So what happens chemically, okay, and let's look at what happens to the electrons, okay. For example, within nitrogen, okay, each nitrogen atom shares 3 electrons with each other, right? So nitrogen is in group 5, so there are 5 electrons in the group number actually represents the number of electrons in the outermost shell, okay. So if nitrogen is in group 5, it has 5 electrons, so this nitrogen atom has 5 electrons represented by the 5 black dots, and this other nitrogen atom also has 5 valence electrons, okay, represented by the 5 crosses, and each one of them will share 3 electrons, an equal number of electrons, okay, they will share an equal number of electrons, in this case 3 electrons, with one another, right? So total, this nitrogen will have 5 plus 3, 8. This nitrogen atom will have 5 plus 3, 8 electrons, and because both nitrogen atoms now have 8 electrons in their outermost shell, okay, it will achieve a stable octet structure, and therefore, okay, this nitrogen molecule, okay, exists as a diatomic atom, because by sharing electrons in this way, okay, the two nitrogen atoms sharing 3 electrons with each other, okay, they actually form a stable molecule, right? So they exist as a diatomic, okay, gas molecule. So the chemical formula, this is important, the chemical formula for such diatomic gas molecule is that there's always a 2 at the end, right? So they don't exist by themselves. You don't say bromine, the chemical formula is Br. You say that it is Br2. There's always a 2 at the end, right? So if you notice, they all have a 2, okay, because they exist as a diatomic molecule, okay. So same thing for oxygen, alright. It will be O2, right, because it exists as a diatomic molecule, okay. So O2, in this case, you can see from the diagram, okay, you share 2 electrons with each other. So although here I provided you with the dot cross diagrams showing how the electrons are shared, it's just mainly for your understanding, okay, as so that you can better visualize how these numbers are actually derived. Why are there 2 oxygen atoms in 1 oxygen molecule, right? Okay, but most importantly is they just know that for all these diatomic gas molecules, okay, there are 2 of the atoms of that particular element, okay, in 1 molecule. So there's a 2 here, there's a 2 here, there's a 2 in all of them, okay, and that is the main point, right? So O2, we have the 2 over here, right? N2, right? Okay, there's a 2 over here, right? And we have H2, there's also a 2 over here, okay. In the case of hydrogen, it shares 1 electron, right? Okay, so this is not so important now, how many there's shared, so just know that there's 2 of them, 2 of such atoms in 1 molecule. Okay, now we'll move on to how do you actually deduce it by the name. Okay, so for example, carbon monoxide, okay, you can see that there's this prefix called mono over here, right? So the prefix mono, okay, shows that there's only 1 oxygen, right? So monoxide, okay, meaning oxide referring to oxygen. So monoxide means there's 1 oxygen. Okay, mono represents 1. Okay, so in this case, 1 carbon, okay, will actually bond with 1 oxygen to form carbon monoxide. Okay, so mono tells you that there's only 1 oxygen bonded to the 1 carbon atom. So how does that work? Okay, if you actually look at the dot cross diagram, okay, how it actually works is that oxygen, okay, these are the 6 electrons from the oxygen atom, okay, so as represented by black dots. Carbon has, because oxygen is in group 6, so there will be 6 electrons in the outermost shell, so 1, 2, 3, 4, 5, 6. Carbon is in group 4, so 4 electrons in the outermost shell, so 1, 2, 3, 4 electrons as represented by the crosses. Okay, and this is the sharing, right? So oxygen will contribute 4 electrons, okay, and carbon will contribute 2 electrons, and overall, okay, both atoms will now have a total of 8 electrons each, okay, by sharing different numbers of electrons with each other, right? So carbon shares 2, oxygen shares 4, right? So carbon only shares 2, oxygen shares 4, right? Okay, so yeah, as you can see, the rules for covalent compounds are a lot less. You cannot really generalize them, right? So they are more specific to what atoms are actually sharing electrons with what atoms. So now we have sulfur dioxide. Okay, so we have the prefix di. Okay, so the prefix di, okay, it means that di represents 2. Okay, so dioxide, okay, means that there is 2 oxygen So that's why we have two oxygen atoms, O2, bonded to one sulfur atom, right? So sulfur dioxide is SO2, right? So here I've included the diagram, okay? As you can see, it's quite complicated, right? What happens is that the one oxygen, okay, for example, let's look at this oxygen atom on the left, it will actually not share any electrons, right? Whereas the other oxygen atom will actually share 2 electrons, right? So this oxygen will share, the sulfur will contribute 2 electrons to share with this oxygen. So this oxygen will have a total of 8 electrons, which is a stable octet structure. Sulfur will contribute 2 for sharing to this oxygen as well. So this oxygen now has 8 electrons, outermost electrons. It's again stable octet structure. And this sulfur, because sulfur is in group 6 as well, so it only needs 2 extra electrons to be shared in order to achieve stable 8 electronic structure. So it only shares 2 electrons with one of the oxygen atoms, right, to be able to obtain 8 valence electrons, okay, to achieve stability. Okay, but you don't really have to know or remember this. I just included this so that you can understand how come we usually just derive chemical formula for covalent compounds based on the names of the compounds, right? Instead of trying to understand them in terms of the sharing of electrons, right? So same thing. Okay, now we'll just look at the name nitrogen dioxide. So di means that there is, okay, the prefix di means that there is 2 oxygen atoms. Okay, dioxide means 2 oxygen atoms, okay, bonded to 1 nitrogen atom. So nitrogen dioxide is NO2. Okay, last but not least, okay, we'll just briefly try to understand, okay, how to actually obtain the chemical formula of acids and bases. Okay, how do we actually sort of name acids and bases and derive the chemical formulas of acids and bases, right? So I'll just briefly explain what is an acid. Okay, we'll go into greater detail, okay, in the later topic. But for now, okay, just know that an acid is a substance which has hydrogen ions, okay, when dissolved in water, right? So basically, it has a hydrogen in it. Okay, just understand it as containing a hydrogen atom, okay. And this hydrogen atom, when dissolved in water, will form hydrogen ions, H plus ions. Okay, and it's because of these H plus ions that give this substance its acidic properties, right? But just know that for example, hydrochloric acid. Okay, just know that this hydrogen here, okay, is what is responsible for making it an acid, and therefore HCl is an acid that is called hydrochloric acid, right? So how do we actually name it and derive its chemical formula? Okay, is that the word hydro over here, okay, indicates that there's a hydrogen atom present, and the word chloric over here, okay, chloric, okay, refers to chlorine. Okay, chloric, okay, refers to chlorine. Okay, so the chemical formula for hydrochloric acid is HCl. Okay, the hydro refers to hydrogen, and the chloric refers to chlorine. Alright, that's it. Okay, so just give you further examples. So sulfuric acid. Okay, so here hydrochloric acid is a little bit different in the way it's named. Okay, but just know that the hydrogen atom over here, it can either be called hydro, which represents hydrogen, okay, or it can also be called an acid. So an acid by default will mean that it has a hydrogen atom there. So when you see the word acid or you see the word hydro, it means that there is a hydrogen atom here. Alright, so let's move on to the next example. If we have sulfuric acid, the word acid shows us that there's hydrogen atoms, okay, and sulfuric, okay, is actually referring to sulfate ions, right? So sulfuric refers to sulfate ions, acid refers to hydrogen ions, right? So when we are talking about the chemical formula of sulfuric acid, okay, it is actually H2SO4, right? Yeah. But why is there a 2 over here, right? So I'll just explain this. I'll just do a recap of the valency, okay? So the reason why there's a H2 is because we have hydrogen, okay, valency is 1, as we have already learned, and sulfate is a polyatomic atom with a 2 minus charge, okay? So hydrogen usually exists as a, in this case it is a plus, okay, not a minus, okay, it's a plus, because acidic properties usually come from H plus ions, okay? So H plus 1 charge means valency of 1, 2 minus, charge of 2 minus means valency of 2, so I will swap them around, 2, 1, okay? So there will be 2 hydrogen and 1 sulfate, okay? So therefore the formula is actually H2SO4, right? Okay, so just going on nitric acid. So acid shows that there's a hydrogen, okay, and nitric comes from the nitrate ion, okay. So the chemical formula of nitric acid is HNO3, right? Acid means that there's a hydrogen, nitric means that there's a nitrate ion, right? What about something that's a little more complicated? Ethanoic acid, okay, it's the same thing. So acid refers to hydrogen, okay. In this case it's arranged slightly differently, okay. So acid comes from this hydrogen here, okay, and ethanoic, the word ethanoic refers to an ethanoate ion. Ethanoate ion, okay, refers to CH3COO, right? So you'll learn more about this in organic chemistry, right, in secondary 4, okay. But just for now, just know that the acid shows that there's a hydrogen atom, and ethanoic acid refers to the ethanoate ion, right? So ethanoate ion is actually this CH3COO, right? So therefore the formula for ethanoic acid is CH3COOH, right? Okay, so finally we come to the naming of bases, okay. So what are bases? Okay, so bases actually they are actually basically oxides or hydroxides, okay. So for example, lithium oxide is a base because it consists of a oxygen atom, okay. Therefore it is an oxide, okay. Therefore it is a base, right? And for example, potassium hydroxide, over here it has hydroxide, which is a OH minus ion, is a hydroxide, therefore contains a hydroxide ion, so therefore it is also a base, right? So bases basically they can react with acids, okay, to produce a salt and water. But just know that this is neutralization, okay, neutralization, okay. They will neutralize acids, right, and in doing so they will form a salt and water, okay. We'll go more in depth into the actual chemical reactions in a later topic, but for now just know that bases basically they will just neutralize acids, okay. Okay, so now we will actually so as you can see, the naming of bases is actually quite straightforward, okay. So you have an oxide over here, represents oxygen, okay, and the lithium just represents lithium, correct, okay. The name lithium just means that there's a lithium ion, okay. So the chemical formula for lithium oxide is Li2O, consists of a lithium atoms and oxygen atoms, right? So apply the same valency principle as I have given a recap over here, okay, to derive the subscript of 2 for lithium, right? Because lithium has a valency of 1, oxygen has a valency of 2. So when you flip the valencies, there will be 2 lithium and 1 oxygen. So same thing, hydroxide represents OH, and potassium just means that there's a potassium ion here, K. Okay, so so potassium hydroxide is just simply KOH, right? Hydroxide is OH, potassium is K, right? So the chemical formula for potassium hydroxide is simply KOH. That will be all for this topic. Thank you for listening.